In this session, we're going to review for the final exam, and I'll start with, asking you to be honest on the final exam. I've been informed by another instructor that a number of students were caught cheating using Clegg and other dishonest methods, and these practices were picked up by an examination of the proctoring videos, and there will be three instructors to view all the videos produced on this exam. So I will repeat my prior advice and be honest. As I said in my video previously, I never knew a person who was honest and who later regretted that they were honest. On the other hand, there's many examples in the media of people who cheat and certainly regret it after they get caught and sometimes serve time and whatever. Um, Detailed instructions for taking the final exam are available in a separate video previously listed, and associated document with that video in module 13.5. You must be familiar with this material. Otherwise, you're going to have problems, just like some people had problems on the midterm test. All exam problems will be taken from the homework assignments, statements shortened and clean and changed, and the numbers are always changed, and there's many versions of each problem so that no student gets essentially the same test. Um, uh, Final exam will have 10 problems, and they'll be 10 points each, and they'll cover chapters 3 through 5 and 7 through 13. To conclude the review, I'm going to work some example problems. And so I'll start with the first problem, which was homework problem 7-14. And I'm going to work that here for you. Um, the, the problem statement, and again, I recommend you be very careful when you read it and try to record whatever important information is given in the problem statement. This one says, TxDOT is considering the construction of a scenic byway through a rural area in West Texas. It's 12 kilometers and expected to cost $2.5 million per kilometer. Okay, so I'm going to put the P is equal to 2,500,000. I like to write that out per km, and there are 12 kilometers. So we would have to do that multiplication to get the number. You could do it now, you could do it later. The annual upkeep, we'll call that annual operating cost. AOC is equal to $75,000 per year. This is dollars per kilometer. We multiply times the number of kilometers, we're going to get dollars, okay? The improved accessibility is expected to result in an additional income to businesses from tourists of $4.4 million. So that's a benefit to the public. Benefit is $4,400,000 per year. So that's an annual amount. But there's some disbenefits. The disbenefits are $130,000, and that's also per year. And if the road is expected to have a useful life of 40 years, calculate the benefit cost ratio if the interest rate is 8% per year. And we assume compounded annually if we're not told anything differently. So that is the basic data for this. What we need to do is convert this 2.5 million into a dollars amount by multiplying it by the 12 kilometers. So that would be, well, we'll do the multiplication there. I'm going to show it to you down here. 12 times 2.5 million is our present amount, and then we're going to take that amount and we're going to multiply that times A given P I N. That's the generic formula. When we plug into the algebraic formula, we get A given, I'm sorry, to the specific values formula, we get A given P at 8% for 40 years times 12 times 2.5 million. So that would be basically 300 million, I believe. But when you spread it out over 40 years at 8%, you get 2,515,800 per year. Okay, I should note that that's a per year basis. I did say annual, so but that's per year, and then we add in as another part of the total annual cost the $75,000 for upkeep and so on. And when you add that in, you get $2,590,800 per year. Now, so we're going to take the net benefits divided by the total cost, and they both have to be in annualized or dollars per year. But when you do that, you have the 4.4 million, 4,400,000 minus 130,000 over the total cost on an annual basis, $2,590,800. When you do the calculation, you get 1.65 for the benefit cost ratio, and that's greater than 1. So this means that this project is economically feasible, acceptable. The next problem that I'll read for you and solve for you is a modified version of problem 9.7. In this case, to improve packaging, package tracking at a UPS transfer facility, conveyor equipment was upgraded with RFID sensors at a cost of $345,000. So most likely that's a present cost. It's not in dollars per year, it's just dollars, $345,000. The operating cost is expected to be $148,000 per year for 3 years. Okay, so I'll say A 1 through 3 is equal to $148,000 per year, and the next year, the 4th year, that's A4, well, it'll be $210,000. So the operating cost is constant for the first 3 years, but in year 4 it goes up. The salvage value of the equipment is expected to be $140,000 for the first 3 years. So F1 equals F2 equals F3 equals $140,000. Of course, you'll only receive that at one point in time, depending on when you take this equipment out of service, if in fact you you ever take it out of service. And then it says, uh, um, but due to obsolescence, it won't have any salvage value in year 4. So F4 will be equal to 0. The interest rate is 10% per year. And we assume compounded annually again. The maximum life of the system is 4 years. Determine the economic service life. Remember, economic service life, abbreviated ESL, is the number of years to keep equipment that minimizes its cost or maximizes its value. And then the last statement here says use negative numbers for cost and enter your answer as a negative annual cost. So the first thing we have to do then, this is an economic, we have to say, okay, well, what if we keep it at 1 year? So let n equal 1. In other words, what if we keep it just 1 year? What is the annual cost? Okay, so what we're going to do is, I'm going to do is draw the cash flow diagram that would occur if you just kept it 1 year. And then I'm going to find the annual worth. Well, the cash flow diagram is you spend $345,000 at time 0. So that's there. And then your operating cost for year 1 is $148,000. That's a cost. But if you only keep it 1 year, you can salvage it for $140,000. That's a revenue. And so now we're going to say, okay, the annual cost to keep it 1 year, call it annual worth, at 10% will be equal to, this is P times A given P, so this will be P times A given P. I'm going to write the generic formula because I'll use that formula again and again, plus the annual operating cost, A times, well, that'll just be A, okay, AOC, call it, and plus the salvage value, F, A given F, I, N. Well, it turns out, since this is at time 1 and this is at time 1, they're just going to be whatever the number is. So I'm going to have minus $345,000. A given P, 10% for 1 year. That's all I'm going to keep it, okay? And then you're going to have minus 148,000 because that's just a single cash flow at time 1. And then we're going to have plus 140,000. Well, A given F, 10% for 1 year is just 1. This number goes to 1 because it's at time 1. This number here will end up being 1.1 because it's moving this money 1 year into the future. So we'll have basically 300 minus 345,000 times 1.1 minus 148,000 plus 140,000. When you compute all that out, you're going to get this number right here, which is minus 387,500. Now I'm going to set up the cash flow diagram if n equals 2? I've got to do this for n equals 1, 2, 3, and 4 because it says this system could last as long as 4 years. Okay, so I'm going to say, well, what if n equals 2? What's the cash flow diagram going to look like? Well, you still have your initial cost, $345,000. In year one, you're going to have operating costs of $145,000. In year two, you're going to have operating costs of $145,000. And then at the end of year two, now you'll get your salvage value. So that's the cash flow diagram if you keep the system 2 years. And I'll write the equation now for related to that cash flow diagram. Well, first of all, this series here is an A series, so it's already annualized. So I can just say the annual worth, I should subscript this. This is 1 year. This is going to be 2 years at 10% equals minus 345,000. But now it's not just spread over 1 year like it was up here, up there. It's going to be spread over these 2 years. So this is going to be A given P, 10% for 2 years. This is an A series, minus 145,000. And then we're going to take that 140,000 and spread it back over, and that's a plus, over the 2 years. That's going to be A given F, 10% for 2 years. When we crank through this, we're going to get minus $280,119. So now the cost has gone down considerably because we're able to spread this initial cost over 2 years instead of just over 1 year. Then we're going to do the same thing for n equals 3 and for n equals 4. For n equals 3, I'm going to show you then the equation. It's going to look so much like when n equals 2. It basically, but we're going to now spread the 345,000 over 3 years. We still have the 148,000. The first 3 years, it's the same amount. Okay, it's only in the fourth year that it goes up to 210,000, and then we'll have a salvage value at the end of year 3, which we can bring back A given F. Okay, at 10% for 3 years. Then when we crank through that, we get $434. Now I am going to do the cash flow diagram for you for n equals 4 because things change there. And it's going to be a big change in the way we deal with this. So when n equals 4, our cost kept going down for the first 3. But when n equals 4, the cash flow diagram is going to look like this. Year 1, we're still going to have minus 345 year times 0, the beginning of year 1. And then we're going to have years 1, 2, 3, and 4. And in years 1, 2, and 3, the cost is 148,000. But in year 4, it goes to 210,000. And then finally, of course, if we keep it 4 years, then the salvage value will be 140,000. Oh, no, it won't. It's going to be 0 because this says let's see, the salvage value of the equipment is expected, let me get that down here, is expected to be 140,000 for the first 3 years. Actually, it's not for, it's just for one of those 3 years, of course. Salvage value only occurs once when you, at the end of life. But due to obsolescence, it won't have any value after year 4. So that's it. So that's going to be a 0. And so now I have to draw develop the equation for the annual worth if you keep it 4 years at 10%. Well, now I get to spread this 345,000 over 4 years. So that's going to help. The more years I spread it over, the lower it gets. But then I have this 148,000, which I have to spread that over 4 years as well, okay? But it's really only for 3 years. So what I'm going to do is take that 148,000 per year in year 1, 2, and 3 and bring them back to the present. Well, that's a uniform series for 3 years. So I can just multiply it by P given A, and that'll get it back to the present time. P given A, 10% for 3 years. But now this money is at time 0. So I need to get it spread over to 4 years. So I just multiply it just like I did the 345. A given P, 10% for 4 years. Now I have this 210,000 sitting out here at year 4. I haven't accounted for that yet. And that's a minus as well, okay? The salvage value is 0, so I don't have to worry about that. So I'm going to have minus 210,000, and I can spread that over the 4 years just by going A given F, 10% for 4 years. If you do that, and that's not exactly the way I did it in this typed version here, I actually brought the 210 all the way back to the present and then did it with A given P. But you can either bring it back to the present, do A given P, or you can just leave it right here and do A given F. Either way, you're going to get the same number, and that's minus 270,197. So now we have the different options here. If we keep it 1 year, the annual cost is $387,500. 387,500. If you keep it 2 years, it's 280,119. If you keep it 3 years, it's 244,434. And if you keep it 4 years, the annual cost is 270,197. So the best annual cost is at 3 years, and so that's the economic service life. The economic service life is 3 years, and the annual worth at that number of years is $244,434. So that takes care of problem 9.7. The next problem is 10.34, and thank goodness it's shorter. So I'm going to go ahead and show you that problem. To retire at a decent age and move to Hawaii, an engineer plans to trust her account to an investment firm that promises to make a real rate of return of 10% after commissions and fees. Inflation has a historic rate of 4% per year, and the account balance is currently $422,000. So that must be like currently that's present value, right? And then part A says to retire in 15 years. So we're talking about, we're talking about P equals $422,000. And we're talking about N equals 15 years. And no further deposits. So it's just a single payment there at time zero so far, and determine the account balance in future dollars. So this is an inflation type problem. To realize a real rate of 10% per year. So that problem is not really written very well. It should be okay. That's good. It says real rate 10%. So we're gonna though want to use the market rate. That's called in the inflation chapter. The market rate is called I sub F. That means that rate includes I and it includes the inflation rate F. Well, that's what was given to us up here. I is equal to 10%. F is equal to 4%. So I sub F, the formula, is I plus F plus the product, I times F. So we now have I sub F equals 10%, which is 0.10, plus 4%, 0.04, plus the product of those two, which would be 0.004. And if we add those three together, we're going to get 0.144 or 14.4%. So that's the rate we have to use to get F. Okay, so determine the account balance in dollars. Okay, so F is equal to P times F given P, and we're going to use I sub F and N equals and we know that's 15. So this is going to be 422,000 F given P, 14.4%, and 15 years. And if we look that up, we will get this number right here, $3,174,701. And that's going to be at T equals 15. That's the answer. So I have one more problem to work for you, and that'll conclude review. I could go on working many problems, but there's only a limited amount of time here. An automated shuttle retriever system has a first cost of $350,000, a depreciable life of 5 years, and an expected salvage value of 20% of the first cost. Using MACRS depreciation of 20% rates of 20%, 32%, 19.2%, and 11.52%. Well, if you've worked some homework problems, you realize MACRS with those percentages, that's 5-year property. Normally on the test, and I will give you the MACRS table, so you just have to know how to use the MACRS table on an MACRS problem. And these are percentages, by the way. Didn't say that, but they certainly are. Oh, there it is. There's the percentage sign. And so it says respectively, so that means for years 1 through 4. Determine A, the depreciation for year 3. So we want to find D sub 3. All we do in MACRS, and this is true always, you take the original basis, which in this case is $350,000, which is basically for an asset, it's the installed price, and you multiply it times the rate. Well, if we're talking about year 3, this is year 1, this is year 2, that's year 3, that's 19.2%. So that's 0.192 as a decimal, multiply it, you get $67,000 to $67,200 for the depreciation in year 3. Part B says, what's the book value at the end of year 4? Well, the book value is the original basis minus the sum of all the depreciation you've taken. In general, I would write this as BV4 equals the original basis, which is 350,000 minus the original D1 plus, this is minus D1 plus D2 plus D3 plus D4. Remember, the capital D represents the depreciation in that year, and the D1 will be equal to small d, that's the rate, times the basis for MACRS depreciation. And D2 will be small d times the basis, and so on. D3 will be small d3 times the basis. And finally, D4 will be small d4 times the basis. And this is D1, little d1. This is little d2, d3, and d4. And the basis is always $350,000. Never changes in MACRS. So this will be, as the author shows, the book value at the end of 4 years will be the 350 minus the 350 times the sum of all these depreciation factors. That's 20%, 32%, 19.2%, and 11.52. You do the math and you get $60,480, $60,480, and that would be what you enter with. And so that concludes the review for the final. You've taken the midterm, you know how the system works, so best of luck.